the faculty members, all the TPOs, all the students, all the management committee members of various colleges who have taken out time today to be here in this WINTalk series brought to you by Task and HYSIA. WIN is an acronym for what industries need. And today we'll be talking about what industry needs in the field of data analytics and AI. Before I start, I would request my colleague and collaborator from HYSIA, Nirja, to introduce about HYSIA. Over to Nirja.
Thank you, Shrikant. It's a pleasure partnering with Task, and we have done several programs in the past also. HYSIA, as all of you know, we have done several job fair for students, freshers. This is a unique industry initiative. It's a not-for-profit organization that brings together various ITS organizations in Telangana under one umbrella to network, share knowledge, and work closely with the government and other industry bodies for the business growth, social development, economic prosperity of the state. For us, this program is very, very important, and it is our initiative as part of our Industry Academia Connect program, where we want to increase employability of the students, because it reduces the training time that is required to assimilate these students into workforce. So this program is very important. That's the reason we are collaborating with Task and bringing you this program. Today, you will be face-to-face with two best tech minds of the city. I'm sure that you will have a lot of great takeaways. Thank you, Shrikant. Over to you.
Thank you, Nirja. Since the topic for today is data analytics, and people normally, whenever they talk about data as the new oil. And a lot of predictions have been made, and I was going through some of the reports where it says that the data analytics domain market, domestic market, I mean to say the India market, not the domestic market, is expected to reach, in fact, it reached $45.4 billion in 2021 itself, which is a 26.5% growth. In India, if you look at the total ITS market size, it was about 23.4% in 2021, which is expected to grow, in 2026 to 41.5%, which would mean by the year 2026, we would be doing about $118.7 billion as far as data analytics and AI market goes. Looking at this market itself, of course, presently it is driven by about 50% of data analytics, things happening from coming from US itself. But look at it, I think in India, the market is expected to grow. And what we have seen with the current market itself, that about 1 in 3, which is about 34.2% analytics professionals in India today are engineering graduates and other graduates, and about 21% are MBA and postgraduates. The other interesting fact is that 28.1% of these analytic professionals in 2021, as per the report, were women itself, which is extremely heartening. So as you can see, this particular sector is a growth sector. It has got multiple job opportunities. And that's the reason why today we decided to talk about data analytics itself. And as my colleague Nirja said, we have some of the best brains as far as this particular topic is concerned. So without any further ado, let me introduce the eminent panelists and speakers to you. Ms. Jaganamba is the Associate Vice President and Head Data for Digital at Infosys Center of Emerging Technology Solutions, which is part of the Infosys group itself. She's extremely passionate about building next generation client relevant solutions in data analytics space, to be on a on a continuous journey, making Infosys a connected data organization. That's her passion. She has a master's degree in computer science from University of Texas. She has an overall work experience spanning over 2 decades and has been with none other than Infosys for over 10 years plus now. Prior to joining Infosys, she had been consulting in multiple organizations across the globe. So that's about Ms. Jagdamba. Welcome, ma'am, Jagdamba Garu. Welcome to this WINTalk series. Next, we have Mr. Ravi Kumar Miduri, who is the EVP Digital Solutions and IP from InnoMinds. He heads the global responsibility for creating digital solutions and intellectual property for InnoMinds. As part of the role, he provides enterprise solution and product engineering services using advanced technologies for the InnoMind customers. The solutions expertise spans vertical solutions in banking, healthcare, manufacturing, automotive, agriculture, telecom, and it covers the entire data and AI life cycles itself. He's a core contributor to the iFusion platform of InnoMinds, which provides autonomous AI capabilities. Ravi has also got 2 US PTO patents in pattern search and 2 more pending in feature engineering and pattern search space reduction. Currently, he is researching in application of segmentation and sequence learning in traditional data sets and solving space-time problems. Wow. Ravi also leads a blockchain initiative at InnoMinds and works with clients and partners to build disruptive solutions and services in BFSI sector, healthcare, supply chain, around identity, onboarding, tracking, contracting, and payments on blockchain. He is well known and has spoken at multiple international events on blockchain, evangelizing the increasing adoption of the technology. Ravi has been with InnoMinds for more than 8 years. Before joining InnoMinds, he worked with Verita Analytics, Satyam, Reliance Infocom, ICICI Limited. An alumnus from IIT Madras and IIM Calcutta, he has received several international and national awards for innovation, design, and process management. So welcome to the WINTalk series, Ravi Garu. So without any further ado, let me start by asking you the first question, Ravi Garu, which is more in terms of if you could help us understand, right? We used to talk about data earlier, and then data was not that important, but information was. So what is the journey? How exactly has this field come up? Why is it that people call data as the new oil? And help us understand the complete journey. Over to you. You're muted.
Oh, I'm sorry. Yeah. Now I'm unmuted. I hope you can hear me.
Loud and clear. Thanks.
Yeah,
Please carry on.
Yeah, data is indeed the oil, and there is another another adage like that, which is data is the soil. Which also basically means that it is a renewable resource, which oil is not, and also a sign of fertility, right, and creation, right, which soil is a sign of fertility and sign of creation. So I think I'll just answer this question: why data is so important, right? And we all have some of our unicorns in the US and in India and in different geographies to see and why they are valued so much compared to say others. Let's if you just take Uber, right? Uber's valuation is more than the combined valuation of all the automotive companies. Right. And if you take Byju's, for example, which is like stupendous valuation, right, of probably more than $15 billion, if I'm not mistaken, is more than all other edtech companies, right? And why is it? And why does the market believe that these companies are going to succeed and then grow fast and and add a lot of value? And the answer is that these are digital-born companies with a focus on data, right? And they use the not just every opportunity available to understand the customer, every opportunity available to understand the operations and digitize all aspects of the business, but then they also, sort of mine the data that they have, to provide better experiences, to make things more efficient and so on. And that is why these are the companies, that the markets love. And these are the ones that are, tipped to be, great value creators going forward. So data is indeed, the oil, and, all businesses, today, they realize that their assets are not just their trade secrets, not just their products, not just their people, not just their information systems, but the data also. And this is one prime asset still waiting to be unlocked from a value point of view. That, I hope that answers the question.
Yes, sure. Would you also wanted to share some slides with
Right.
the
Yes.
participants? So do let me know which slides so that my
Yes.
colleague Sanjani can pull those slides out for you.
Yes. So, I wanted to make this brief. We got only about an hour and don't want to make this a classic lecture. So let's just quickly jump to the overall space of analytics, right? And, if you can move on to the second slide, right? So analytics, there's so much of opportunity in analytics, and in my estimate, personal estimate, and something that the industry analysts echo, right? As more and more repeatable tasks and tasks that humans were doing are now getting automated. We've seen it in several industries. With automation taking away the burden of those tasks from human. What then remains is to then direct these automation with intelligence. And what then remains is to continue to be creative and have a problem solving approach. So my estimate is that 1/3 of the jobs going forward, maybe in a decade from now, will be analytics jobs. And these will be jobs that require thinking, creativity, and application of the mind every day versus doing things routinely, right? And doing things per a process, out and out every day. So that's the opportunity for analytics. 1/3 of the jobs in any domain, in banking, in telecom, etc., with automation and software defined everything, you will have most of these manual tasks other than those that will have to be physically done. But even those with robotics and, and digital twins and, now even metaverse, you will have a lot of things digitized even in there. So that's the opportunity for analytics. Analytics, can be split into those that are, reflecting on the past and looking at what happened and trying to analyze that, which is basically the factual analytics, which is what you see there, the historical analytics, and analytics that are prescriptive and predictive of things that are likely to happen, right? And the whole point is to make data useful for business in getting some value out, whether it is acquisition of customers, better experiences, better operations, better risk management. So that's the world of analytics. If you can skip the next 2-3 slides and quickly get to the slide number 6. So these are all the different types of analytics. I won't, go over that. You can go over a tutorial and then see that, analytics means things like time series forecasting, cross-sectional forecasting, classification, clustering and grouping people or things or items. So that's the world. But who is the analytics professional? Who is the person who is delivering this analytics, and what does that person need to have? And I define this as an intersection of 3 key, domains of expertise, right? One is definitely programming, right? So an analytics professional must be able to manipulate data. You can manipulate small data in spreadsheets. You can manipulate, you can manipulate by hand, let's say a few tables with 100 rows, etc. But you cannot manipulate big data on traditional tools. So you definitely would need to know programs, and these are programming in R, in Python, in Julia, etc. And you need again some kind of scalable environment to do this programming, and that's where things like the cloud and maybe something like Spark or Spark ML comes into the picture. So that you are able to program in a distributed way and manipulate the data. Second part is you need to have some background in math and statistics. So after all, numbers and analyzing numbers, need that mathematical and statistical foundations. And most of you already have that. We've been learning this from class 10th, from just the mean median mode, to standard deviation to advanced like distributions and even more advanced, right, regressions, and then even more advanced, right, like uh, these matrix transformations, matrix inversions, which go into the heart of any neural network. Right? You need to have some background in that. And lastly, you need to know the domain and the business. So project after project, we see that while professionals can do the programming, they have the math background. If they are not able to apply it in a certain domain, then they tend to struggle. And this is domains like healthcare, domains like telecom, banking, and financial. You need to know the domain and its dynamics and set up the problem in such a way that the data and the explanations, etc., and the inferencing fit in into that domain's paradigm. So that's the analytics professional, and that is what you should be aiming to acquire since you're starting this journey to seek a job in this analytics domain. Next. Yeah, these are the industries. You can see every industry, and those that are consumer focused, the ones that are marked in green and blue, these are the consumer focused industries where the scope for analytics is even more, because people are the hardest things to be analyzed. Machines can be analyzed far more easily, right? People are the hardest things to be analyzed, and we know it, right? It's so hard for us to understand each other despite years of association. But you can see, therefore, that the consumer industries in particular have the greatest focus on analytics, and their business is going to be mostly driven by how much they know their customer and their operations. And that's what I meant, when I talked about the unicorns. The next slide. Yeah, so this is what I just want to end my presentation with, just this small tip here, that analytics is a creative problem, and it's not so easy to get. It's not about algorithms. As recently as like yesterday, we took some data from one of our customers, like PepsiCo, and we analyzed the data, but we got the results of the data, but that's not enough. It's a creative process of what is the data that I have got? Is it fit to do analytics? And what are the outputs that I have got? Can it explain the business based on the outputs and so on? So there is a story built out with analytics that you can see here. And the effort increases, exponentially to get the story out. The effort of just the data manipulation and effort of just running the algorithms is a fraction. A much larger effort goes into how you're drawing the story and what conclusions, inferences, and thereby the prescriptions you have drawn, and from that, and that requires creativity and patience. So nothing comes out as quickly as possible. So all I would advise as my let's say final comment on this is, it's a creative exercise. Analytics is not just about process. It's a creative exercise, and it requires that problem solving and bringing different dimensions of view and having the patience to work with the data and get that story out. And that's my sincere request to you, to develop those skills, the creativity and the patience to bring that story out. So with that, I would like to end my slides, and if Srikant Garu has any questions, I'll answer. And we are keenly awaiting Jagadamba ma'am's presentation, and it's very rich experience of hers that she will share.
Thank you, Ravi Garu. So, Jagdambaru, we spoke about, and we used to have a thing when we started, more than 3 decades ago, when I moved into the field of programming and software, garbage in, garbage out. And as mentioned by Ravi Garu, the data itself, unless until that is clearly understood and decisions can't be made. So help me understand from a perspective of a large organization like Infosys, right? What all are you doing in the field of data analytics and AI? Your perspectives, please, ma'am.
Sure. So what what happens is, let me bring Infosys first. Infosys is doing a lot in this field. We have multiple service lines which are invested in it based on the number of clients and the variety of experience which we need to basically take the client's problems and solve them. So there are a lot of specialists needed, and the way we have to tackle all of this is starting from training, making sure we are able to customize to the client requirements, making sure we understand the client's landscape. Like Ravi Garu said, it is about storyboarding, seeing how to put the client first and take it through in a way where the client feels the journey worthwhile to invest in Infosys. So where do you start, and how do we basically make it worthwhile for the entire organization to be invested in data and analytics in some form? Like Ravi Garu said, it's data is oil and it's also soil because it's very fertile. Now, how do you remove the weeds which basically come from the data, right? So you have a lot of pre-processing in the data space, which you have data everywhere. Data is starting. Data was always there. It's not that it started today, it is available today. It was always there, and it is becoming more and more as we have 5G. We are going into all the newer aspects of metaverse and various other aspects, which basically take data into a newer journey. But what do we do with the historical data? What do we do? How do we blend it with the current data and make predictions for the future? That is where I think data and analytics completely merge together to make the story complete. So there is a lot of learning, and there is a lot of application of domain and technology both together. So until you solve a client problem, what you do with data is immaterial. So if you are solving the client problem right, which it means that you are doing your job right. So there are a lot of things which you can do to basically make the entire journey worthwhile. And Infosys actually is looking at Springboard as a very good way to engage with Telangana government as well as HICIA to make it available to the larger audience. So now, how do you make learning available to the larger audience, right? There is so much information available everywhere. So everybody can get lost. So this is a platform which is an integrated platform available for everybody. Whatever you want to learn, you please learn there. Then there is also this option of taking that learning and taking it to the next level, where you have environments where you can practice, and after you practice, then you make it relevant. After you become relevant with the technology, now this actually enables you with the technology. After that, take a client problem, understand the story, what the client wants to say, and how do you make the data relevant, data available for forecasting prediction. So you look at the data, see the modeling, do all the required aspects, and then, like Dr. Ravi said, it is about uh, storyboarding as well as mathematics. So how do you analyze the data to make it relevant for current as well as for future? Current data, for example, if you take any of the stock trading aspects, right? At the end of the day, by the time the market closes, they will have to reconcile their stocks. They have to make it available whether they made it successful for the day or not. At every point, it is real time. So if there is something like real time analytics which has to be done, to think about the amount of data to be processed, and how the knowledge has to be churned from the data. So there is so much learning which has to be done, and the expertise has to be as maximum as we can get. So that is where I would say learn, learn, and learn, and make it continuous learning along with implementation. So you keep learning. both technology, business, then you implement whatever you can. Then as it changes, because analytics was always there, we were doing it in spreadsheets, we were doing it in pieces of paper, because everybody actually at the end of the day has to report profit or loss. This was always there. So how are we automating all of this to make it worthwhile? So that is the engagement which we have to get into. So there is no right or wrong way to approach it, but I would say learning and making yourself relevant and engaging in every aspect of whether it be hardware or software, and how to blend the hardware with the software and making it matter. So you should be able to create some dashboards, and this is all about you doing it for your passion. So your passion is what drives what you want to do as a career. If your passion is right, your career is going to be set. So that is what I would say is the best way to approach for students and colleges, because if we get everything where learning is put first, not the grades, not whatever has to happen comes after that. So if you take care of learning and put learning as your only priority and invest into the journey of analytics, it's not going to be a 1 day 2 day thing, because journey is continuous and the change is also as fast as the continuum. So I would say keep investing into this learning, and we should be able to do it all. So if you can go to the next slide.
Sunny, can we move to the next slide? Yeah, thanks.
Yes, sir.
So now, if you really look at it, analytics, right? We are putting analytics into our learning platforms as well. We are giving you the, now that everybody is online and we have to work from home, and we are, there are so many other things which has to be done from home. How do you make learning experience rich enough where students are able to learn and make the best of the learning that they are involved in? Because hardware and software require collaboration. So collaboration becomes a very key part of learning. So we are trying to see what best we can do. But I would say, even if every platform is available, please look at networking and in-person learning, because that really makes a difference. You have to sit together to solve problems at some point. So look at a hybrid level of learning, and that makes it worthwhile for you all. If you go to the next slide, please. So if you look at the way the digital literacy, right? It is not about data and analytics any further, because data and analytics have become such buzzwords, right? They are becoming the background and the backbone of any type of implementation or business. Everybody wants to use data and analytics. But how do you get data analytics right? You have so many different ways. You have to look at privacy. You have to look at how the client data is protected. You have to look at security and make sure the data is protected from threats, and that becomes an aspect of analytics. So if you look at technology and domain, in both ways, the analytics and data can be used to drive a business in a very holistic way. And we should look at making sure the entire digital literacy is brought into picture with a specialization of what you want to focus on. Because if you want to get it all right, I don't think even we are there. Even we are learning. So how do we get it to a point where we are embarked on that journey, we are learning, but don't be intimidated? I think that is the biggest thing which will happen, which is, if you see the way the movement of technology is, there's a chance that we get intimidated. So we should not get intimidated. We should see how to learn maximum and keep continuously learning, understand the peripherals, the outliers also in the technology and business, and see how you can apply your learning into technology and business to drive a difference for yourself and your career as well. With that, I will close. Thanks for your time, Andy.
Thank you very much. Very, very relevant points, and thanks for bringing out the thing about learnability as being one of the key skills that are required by corporates across the globe from learners. And I think you put it in the right perspective. When we say 17 plus 4 plus full stop doesn't exist any longer, it is 17 plus 4 plus 40. Till the time you are there in the work life, you will keep on learning new things, learn, unlearn, relearn kind of scenarios are there. And I think we have been working very, very closely with Infosys and Springboard platform. And if I'm not wrong, we have about close to 40,000 plus students who are benefiting from all these programs that you spoke about, as part of the Infosys task partnership on for Springboard. So thank you very much on that. So now let me, quickly, since we spoke about the jobs, and if we look at the NASSCOM Zinov report and everything else, we are talking about by 2024, about 105,000 new entry-level jobs will emerge in this area. So let me quickly, do a kind of I'll not call it a quick fire round kind of a thing, but let me go across certain job roles that are existing in this domain, and probably I will rotate it amongst both of you to find out how does one become those people and how do you, aspire to do that job role. In the meantime, my request to all the participants who are there, we will be taking up your questions later on. Please type in your questions, etc., so that once we are through with our discussions, we can take your questions. So let me move on to you, Jagdamba Garu, and ask you, if we look at the data scientist, what kind of qualification, what kind of experience, what kind of skills?
So data science is a journey again, right? And qualification is really not the driving factor for becoming a data scientist. It is about your learnability and your application capability, right? So learning is one aspect. So if you take a business analyst, he still can become a data scientist because he will know the business aspect of it. So what you really need is the skill to learn, and you start off with something as basic as a Python, Java, Spring Boot. These are all skills which are already there, available. Now there are also no-code, low-code platforms which are coming in, which make learning easy. Thereby, analysis becomes the core focus, right? So what you need to understand is how do you take a business problem, slice, dice it, make it relevant, do a design out of it, and apply your learning. So what are your core skills? Python will be a core skill because you need to understand all the libraries, how to apply them. And then after you know Python, there is still a big gap. Okay. So now what do you do with Python? Python has, you have a lot of GitHub code bases already available. We have so much of crowdsourcing already there. We have so much of open sources already there. So now, how do you make all this into picture and make your problem statement relevant and scalable and explainable? So explainable, scalable, and responsible. There are 3 levels of making sure data science is approached. So responsible means you make sure your data, once you are doing any analysis, is not reversely trackable. You are not compromising somebody with your analysis, because there's a chance that you compromise people or their privacy, or you have some level of hacking exposures which come into picture by coding. So you have to take all this aspect. So to become a data scientist as such, you have to have a lot more than just coding. Coding is the start part of it. So Python is a good place to start. And then you can look at all the Python related aspects. Then you can slowly get into deep learning. You can get into neural and neural networks. You can look at various other aspects which are around the data to make it all relevant and become a holistic data scientist. So technology plus domain.
Thank you. So let me move on to you, Ravi Garu. We always used to talk about the database administrator. Right now, under this new thing, how has it changed and what would be the qualifications, skills, and experience required for it?
I mean, I think about 8 years back, fortunately, I was in Redwood Shores, the headquarters of Oracle, and I heard, I think, a phrase called the autonomous DB. And it was, I think, a session managed by Larry Ellison himself. And he said that they are designing databases that do not require administration at that time, right? And so the typical DBA's role of monitoring the databases, taking backups, and ensuring high availability, checking and tuning for performance, right? These are tasks that, in my opinion, right now, nobody does. Any of the, the cloud databases, whether these are traditional relational or, the key value stores, they are auto managed, so the backups and high availability and monitoring, they don't have to be performed manually anymore. And even from a query tuning and query optimization, if you heard of Snowflake, you don't have to do indexing. It's all index everything. And the intelligence or, the algorithm within Snowflake figures out, how to, like take that query and so the word database administration has taken new meaning. It is not so much about administration tasks, but a strong understanding of data stores in general, data stores have to be organized, and how the stores have to be, let's say, managed under the context of cloud and the tool that it provides, right? So that's the change, and should we should embrace this technology, and therefore now in our like in for example, we've transformed all database administrators to some sort of ETL developers, some sort of people who can get data in from, say, an on-prem or some system, or including a device, into a store, whether it's on the cloud or otherwise, and then make them, sort of manipulate and mine that data. So I would say that it's no longer administration that is important with respect to database, but it is the knowledge of the tooling that either a cloud or an on-prem provides, and to use that tooling to make databases or any data store for that matter more efficient and responsive to business.
Thanks. So on the same note, another thing which was going on, the architect, how has that role also changed?
Okay, should I answer this?
Yeah, please.
Yeah. Okay, this role has become even more important, than before. As in with the proliferation of technologies and all kinds of technologies. Just on storage, there are at least 10 different storage types, right? Including erasure coding and avoiding erasure coding, and then the object stores, and and the NVM, and the fast interfaces and software defined storage, etc. So I would say probably the most complex job today, probably even more complex than the data scientist, is that of an architect, right? And an architect, not just because of the proliferation of technologies, that's one side to it, but it is also the dynamics of the business. Businesses are hungrier, they want more, they want to get more out of the resources that they already have or are willing to invest, right? And that requires a strong understanding of the business context, the business setting. Whatever industry it is, like say if you take, let's say, retail, and let's say they are now trying to do a hybrid, continue the in-store, but also add an online channel to it. How does this then affect customer experience? How does this then affect, let's say, omni-channel and ensuring that, everything is the same on both sides? So it's, I think, probably the hardest role today, that the architect has to understand the business context, and translate that to a system overview, a high-level system overview that meets that business need, and then break that high-level system overview to individual components, right? And actually, technologies don't matter. It's whether it is Python, Java. Today, it doesn't matter at all. It's just a matter of convenience and maybe what applies to that business. Similarly, whether MySQL is better than Postgres, whether Spark is better than Flink, these don't matter. What matters is, your overall system overview and the ability to break that into individual components and their goals. And then you will have choice of technologies. Given a particular business, they have to choose the one that fits them the most and then go about doing the implementation. So this role, again, to summarize, has become even more pronounced. And they are probably the most crucial guys to achieve the digital transformation in every industry, in every domain.
Right. So over to you, Jagdamba Garu. In fact, there are a couple of new job profiles that have emerged up, which are data engineer, ML engineer, DevOps engineer, and data quality analyst, right? Which probably did not exist in the, when the RDBMS, etc. were there. So in case you can help us understand what are these roles, what qualifications, what skills would be required, so that our youth who are there today across Telangana from the colleges can benefit and see how they can aspire to become part of it.
So I'll actually start off with one point. Today, everybody from colleges are learning about applications. So how to do experience, how to do design, how to do various APIs. They're doing a lot of different things where they're building applications. The data has to go somewhere. Now the data has to go somewhere and coexist with the existing data. If you see, data is becoming so exponentially growing, and the storage is not going to be enough. Now
Right.
Sustainability is coming to picture, right? So if you see, if you don't control the growth of data, you're actually burning the carbon footprint. You're increasing it, right? So why do you want to do all of this? See, if you take data, put all the relevant data into one place, make it available for analysis, make it future relevant, and make sure it is optimized. So that is where data quality, data engineering, data analysis, all these are becoming very, very relevant roles. Because now, previously they were more focused on application development, application design, how do you get the experience out? Because data was all in a silo in some place, most of it relevant for either marketing or sales. So you build an application to render that. Now you want data to be working together. So before they used to talk about data warehousing. Now there is nothing called data warehousing. Everything is real time. So then all that are near real time. It's still not real time, but near real time. So then now the emphasis on data is increasing to such a point where data lakes are what you can look at building ambitiously. So how do you engineer your application to make the data which is available where you want relevant and usable, and make sure the right data is available for analysis? And that is where the pre-processing of data becomes very, very, very critical. And that pre-processing of data is creating these roles. So you are not anymore looking at data becoming the secondary type of a job profile where you learn application development and come in and learn data. Now with the hyperscalers and the various types of optimized solution development platforms which are available, data, learning data and making sure the data is usable. So start with ingestion of data. Now, ingestion of data from multiple sources, making it all integrated, putting it into the relevant data source, maybe on-prem, maybe on cloud, maybe in a hybrid environment. Now, once the data is all there, how do you get the data into the right form and format where you want to do your analysis? So your data quality, because once you bring data from multiple sources, you will have multiple names for multiple things. You will have a lot of redundancy of data, replication of data. Data will be duplicate. So how do you make the data relevant and available for analysis? So these become very critical. Once they are available, then analysis, because of the hyperscalers and the various other availability of basic tooling to get all the analysis done, is actually very, very mature right now, and it is going to mature much further. So you should know what to do with the data. That becomes the critical role, and thereby creating these roles.
Interesting. Thank you. So thank you for helping us understand, why these roles and what exactly is the requirement for them. Moving on, I can see that there are a couple of questions that have already come up. So Anusha is asking, what are the best ways to practice data cleansing? Any one of you?
There are so many open sources already available. See, every enterprise level tool has a open source version of it. So if you really want to learn, there is enough open source, I think, to learn. There are enough data sets to learn and make sure you are applying your learning skills onto your platform and making sure that data is available in the right format. So it's about understanding data from its core. I'll hand it over to Mr. Ravi also.
No, yeah. So on deep learning or even on any aspect of data management in cleansing, there are tutorials, there are online tutorials, and as Jagdamba ma'am has said, if you take an open source like say H2O.ai, there is a community version that is available, right? And you can use that. They have the driverless AI specifically for people who want a quick path, to do the AI. So you can use that, or you can use Data Data Robo. There are so many, or even in the core Python packages itself, right? You can use Keras, as an abstraction over something like say TensorFlow, right? So you can use those to do and there are tutorials for this. But all I would add to what Madam has said is identify a mentor. In my opinion, learning by yourself is great, but learning is that much more enjoyable and lasting, if you have the right mentor, right? So, and our traditional schooling in India has always emphasized that, right? That if you have the right guru, in addition to your self-discipline and your own passion in learning, you will shine, with the right mentor as well.
Thank you, Ben. I absolutely agree with you, Bira, and that's the reason why we decided to do this, especially given the fact that most of our learners in our college are first-generation learners. It becomes very, very crucial for us to help them choose the right kind of sector and industry that they should opt for. So the next question is coming in from Raghu, who says, what is the criteria to say whether a developed data model is good or not?
So I'll start and Ravi Garu can add. So developed data model is good or not is basically the outcome has to be good. So whatever garbage in, garbage out, right? So if your analysis has to come out right, your data modeling has to be good. So the best way to look at it is take a known data set which you can associate with, see how you can play with that data set, analyze that data set using first model the data set, then analyze the data set, see if the analysis is coming out right, and your aggregation or your basic dashboard has the right data which is coming out as outcome. So once the data which is coming out in your dashboard is right, whether it is from a overall perspective, whether it is a trends perspective, whether it is a ranking perspective, you will have to understand your data, model your data, and see if that model is working for different scenarios. Once you know that these scenarios are working, then the data model is right.
Ravi Garu?
Yeah. I think like Madam said it all. I'll just add that this is where experience, judgment, and an inquisitive mind helps. When I started my career with data science, I never believed any data that I got. I used to question, is this data right? Can I go back? Can I see where this data came from? Can I take the raw data, apply the same transformation, and then get to the same data? So I would say basically don't lose the inquisitive mind. Question everything that you see and use the experience and judgment and apply a lot of things, like say the principles of, let's say, Occam's razor. Go for the simplest explanation. And if that is good, then you have the right data model, right? And or in the world of statistics, there are so many techniques to explore the data model and see that this is right. Like, and for example, you can start with simple chi-square distribution. If I got a data set and I have another similar looking data set, which I know is for, like the golden data set, is this data set looking like that data set? So apply a chi-square test of independence and see that these two belong to the same population, and then these are samples from the same population. So my suggestion is that this is the heart of data science. Is my model right? And that's where you have to use the experience, judgment, and the scientific techniques, including the statistical and mathematical techniques, to get this right.
Sure. Thanks. The next question is from Shisha, which is again linked to the data validation process itself. What are the important steps in the data validation process?
I'll let Ravi Garu take this first because I'm making it.
No, you were answering great, man. I don't have any other perspective. But data validation, there is what I would say there are broadly two techniques. One technique is called normative, which is you expect the data to behave in a particular way, and then you test that it is a particular way. For example, if you are, let's taking, say, age, right? We know that probably the ages cannot be beyond 125, it cannot be less than 0. So you have a normative data set. And you also know generally the median age of any country when taken or any group when taken will be a certain thing. And you then see that the data is actually, behaving in a very similar way as the normative data. And then there is another technique, which is the curative technique, which is you see the data in itself, right, without relying on let's say any external input on what the data should be, and then you cure the data that you think is best, in representative, and then get that out. So this could be things like outlier detections and removals, right? Just an unsupervised way of getting into the data and curating that data to get what you want. So that's another technique to validate the data and discard the ones that are not useful. And again, in these two, I will say that there are both statistical methods to do that. Like for example, for outlier detection itself, you can simply put a z distribution, or you can do it like say distance based and do a hierarchical clustering and then break the chains at the extreme ends, or decide where to break the chains and let the remaining data be useful. So there are both scientific techniques available, but again, the judgment plays an important role here, that what is the data and are you understanding the data right, and do you see that as representative of the reality in that business?
Thanks. So, Jagdamba Garu, anything you would like to add?
Yeah, so I very much agree with Ravi Garu, and then what I would add to it is look at it from understanding the data. So validation of data comes more from learning and understanding data. So thinking it from the business perspective, how the data makes sense. So a lot of times there will be data missing, there will be data enrichment needed. So for validation, you need to look at deduplication, you would have to look at enrichment, you have multiple ways. So all of them again form into various places of what Ravi Garu said, but you basically look at how to understand the data set and then validate the data set for the business outcome that you want to achieve with the data set. I think that's what I would add. So business outcome, understanding what you want to do with the data, and then work with the data to make it work for you to achieve that business outcome. I think that is the most critical aspect. So there are multiple ways to do it. And then you can start off with something as basic as classification and clustering. And so that way you basically start somewhere. How you do it is immaterial, but then start somewhere small, and then you try to do a lot more.
Great. Though you already spoke about it, both of you mentioned some useful tools for data. Then it would be good for the benefit of our students if you could again tell some resources, some tools, some websites, etc., which will help them further their data analytics and AI journey itself. So this is a question by Navya.
In Infosys, actually, we have Infosys Springboard, which is a collaborative platform, and you all are already working with that platform. It is available for everybody. We are looking at the latest and greatest technologies which are needed to be onboarded onto that platform. It's a learning platform, which we basically have a version for clients as well as that same type of a version available for students, so that they can benefit on their learning journey. So that is very holistic and available. Now there are also a lot of tools which are okay, Infosys Springboard is a collaborative platform, but where do you start? What do you start learning? So learning is a journey, right? And it's a very big ocean of information available today. If you really want to learn, you can start from anything like YouTube you can go to GitHub, download a lot of code. There is so much information available that to convert that information into knowledge itself is becoming a challenge. So you should basically have a vision as to where you want to go and how you want to go there. Now, I think between Udemy, Coursera, Infosys Springboard, then all the tools available, hyperscalers, basically, you have a lot of, freeware available to test out your skills. And, tools like Talent and H2O, every tool has a learning version, and it is available for students if you really want to learn. But the learnability is the most critical aspect, and learning where you don't get confused and lost, because there is also this chance that if you take too much on and you get overwhelmed and you lose the passion to learn. So you take a structured learning approach. There are so many mentors. Ravi Garu also is a mentor by himself. I am also available. So there are so many other people available to mentor students whom, you can take a very specific way of journey to learn and grow into your career where you want to go.
Great. Ravi Garu, would you like to move on to some specific tools?
Yes. When I was very new to deep learning, I read one book by Ian Goodfellow, and I do have it like a digital version, that I bought. I can't share it because I bought it. It'll be a content violation. But I would recommend that book, and by Ian Goodfellow. In fact, I recently saw some article that he is heralded as, the one who like really like transformed what deep learning is and so on. And it gives a good perspective, therefore. And then I also used to read some tutorials like Deep Learning 4J, tutorials.net. And then PyTorch has, a beautiful tutorial part, on how to use PyTorch, right? There are TensorBoard, and, you can use TensorBoard not just to, understand TensorFlow, but also to visualize some of the models and mine that, right? So these would, I would say, like some of the tutorials. And again, when I started my career, there used to be SPSS and a community version of that. It's available with all universities, right? That itself is a great start. If you just use SPSS, and then there are R tutorials, there are Python tutorials. So these are some of the specifics that I would request you to, try and access.
Right. In fact, last year we also ran a program on ML using Java, where we were looking at data sets and we were trying to see some predictive analysis from that. And that was on different kind of data sets, right from predicting the price of a resale vehicle to multiple other things. So definitely a lot of such programs are being done, and we would encourage our students to go on to that. There are a lot of questions, but we've already overshot the time by 5 minutes. So the last question I would like to pose to our panelists is a rapid fire question, which is 3 words in which you would like to advise our students, right? What they should do to further accelerate their data science journey. So let me start with you, Jagdamba Garu. 3 words.
3 words. Basically, I would only say 1 word: learn, learn, and learn. Okay. But if you want 3 words to already they're embarked onto a journey, they want to go further out, they want to basically branch out. So I would say technology first, then business, then modeling.
Wonderful, wonderful. So technology, business, and modeling. Ravi Garu?
Yeah, it's actually there as a phrase. It's not 3 words, as a phrase, and I completely love that phrase. It's there in the presentation that is shared at the end, and I'll just say the phrase in toto. And I believe in it. Questioning and persistent questioning is the only guaranteed way to learn. You should not be happy with anything, and you continue to question until you run out of questions, right? And that's the only guaranteed way to learn. And that's what I would advise each of you, right? Question, right? Like if it's any aspect of it, why should it be done only this way? And then keep questioning until you run out of questions.
Sure. Thank you very much. It was indeed a pleasure having both of you sharing on data analytics, on the various job profiles, the industry itself, what our students should be doing. Thank you for sharing all these things with our students, Jagdamba Garu, Ravi Garu. It was indeed a pleasure having you with us today. We look forward to your thing where you spoke about mentoring. We would be having, once we do some hackathons or something else, we would love to have both of you as mentors, for our students. Some questions have remained unanswered today due to lack of time. We would, get back to the students with answers to that after consulting our expert panelists. So here, on that note, I would like to thank our panelists and also mention that our next WINTalk series would be on testing. I think it is a segue to what was the statement said last: question and question. And testing is nothing but questioning and seeing the result of it to see whether it falls in the correct frame or not. So testing is going to be the topic that we would be talking about on 29th April, again at 3 to 4 p.m. as part of the HICIA Task WINTalk series. Thank you very much, all the management of institutions, all the faculty members, TPOs, and of course, dear students, for being part of this session. I hope it was useful for you. Do share your feedback and comments as you usually do, and we'd be happy to incorporate your feedbacks into the session as we move ahead. On that note, I would like to thank our panelists. Jagdamba Garu, your presence has been really inspirational for our students. And of course, as I said, 28.1% are there with people like you leading organizations. I think that number was definitely going to go up. Thank you very much, ma'am. Ravi Garu, thank you very much for putting across this thing which is supposed to be a big enigma for most of the people in such lucid and easy manner where everyone could understand and appreciate what goes into the journey of data science and AI and big data analytics, etc. So thank you very much for sparing time. Thank you, Neerja, Srini, Bernie, and the entire HICIA team for partnering us in bringing this WINTalk series to our students and the youth. Also, thanks to the Okta team platform, which is a startup incubated by WeHub. We did the session today. So thank you, Malika, Vinny, and all the team, Sanjani, etc., and all the team from Okta for hosting this. Thanks to tsat, on which this was telecast, along with being on Yahoo, on YouTube and Facebook channels of Task as well as HICIA. On that note, all the best. And as Jagdamba Garu said, learn, keep on learning. Thank you very much. Have a nice day. Bye-bye.
Thank you.
Thank you. Thank you very much.